When population grows, demands on the environment and on public services also increase. In this lecture, we will examine population fundamentals such as population geography and various population statistics, also called demographics, like density, distribution, and birth and death rates. These are important to geographers to help understand the challenges that involve quality of life issues, employment prospects, and sustainability. Population geography is the study of spatial variations among populations and population-environment interactions. Again, spatial variation describes how things are varied from one place to the next. In other words, why are people where they are, and why are they living densely in some areas and sparsely in others? Demography is the statistical study of the characteristics of human population. They are the actual numbers that we see. For example, the total population of the United States is approximately 316 million people. Population data is normally shown in charts, tables, and graphs containing the actual numbers, ratios, and percentages, but geographers also display that information in maps for a visual representation as well. There are four basic dimensions of population geography. 1. Population distribution. We usually look at distribution in terms of an area like a country, therefore how many people live in that country. 2. Population density, again in terms of a country, are they grouped together or are they scattered about? 3. Fertility, how many are born, which includes birth rates, total fertility rates, and replacement levels. And 4. Mortality, how many die, which includes death rates, life expectancy rates, and infant mortality rates. The fundamentals of population geography build from a familiarity with the spatial configuration of the world's population. The population cartogram shows the uneven distribution of population among countries. Unlike conventional maps that depict the land area of the countries, on this cartogram the size of the country is shown in proportion to its total population. At a glance, you can visualize how China's population dwarfs that of Russia, for example. The pie chart shows the 10 most populous countries compared to the population of the other countries combined. Together, China and India account for 37% of the global population, almost as much as all the other countries combined. Population density is expressed in two ways: arithmetic density, which is the number of people per unit of total land area, and physiological density, which is the number of people per unit of arable land. Arable land is the land that can be used for agriculture. The dot map shows the population density of the world. Globally, the pattern of density in sparsely settled regions suggests that people tend to prefer to live in certain natural settings, such as on level land and away from deserts. Nearly 70% of the world's population live within 400 kilometers or 250 miles of a coast, and on just 10% of the Earth's land. The chart shows the arithmetic and the physiological densities of a few selected countries. The higher the physiological density is, the greater the pressure that a population exerts on the land that is used for agriculture. Bangladesh records high arithmetic and physiological densities even though the country has a high percentage of arable land. Generally speaking, fertility refers to the ability for someone to produce offspring. Geographers use fertility to analyze what is happening within a given population around the world. There are two important fertility measures that geographers use: crude birth rates, or CBR, and total fertility rates, or TFR. The crude birth rate is the actual number of births per year per 1,000 people and measures childbirthing trends within a society as a whole. It does not take into consideration age-specific trends. A rate per 1,000 people is used instead of the actual number to compare numbers between places more easily. The higher the number, the more children that country has. Total fertility rates, on the other hand, will help us gauge family size and predict future population trends. Total fertility rate is the average number of children a woman is expected to have during her childbearing years, between the ages of 15 and 49, given current birth rates. You derive the TFR by taking the total number of women between the ages of 15 and 49 in any given population and divide that number by the total birth rates. With this number, we can tell if the population is growing, declining, or stabilizing by comparing the TFR to the replacement level of 2.1. The replacement level of 2.1 is the fertility rate necessary for the population to just replace itself. Logically, you might think that the replacement level should be just 2 to replace both parents, but the 0.1 takes into consideration any females who die before childbearing years or not have any children at all. Looking at the chart, you can see that currently the world's TFR is above 2.1 and therefore growing. Can you see the trend over the last 60 years? The rate at which the population growing is declining. Please pause the video. There are no questions to answer, but take a moment to study the chart. Look at the anomalies of Iran and South Korea. What do you think may be affecting these declines? Well, there are many factors that affect fertility in both directions. These can be biological, social, and economic. Biological factors include reasons such as infertility due to hormone changes in breastfeeding women, diseases and poor diets affecting the ability to conceive and carry children, use of contraception, and women who become sexually active earlier and marry young. Social factors include the low status of women who are forbidden to make decisions about reproduction or have low literacy rates. And economic factors include poverty, putting children at work at a young age, and adult children becoming the sole financial source for elderly parents. Government policies of any country can have a significant influence on the total fertility rate depending on what objective they are trying to achieve. For instance, a government might promote an increase in growth if the population is declining to ensure adequate labor forces in the future and not rely on migration to fill those needs. This is called a pronatalist approach. China, on the other hand, began to implement policies that deterred population growth beginning in the 1950s. This is an anti-natalist approach. For instance, China implemented a one-child policy around 1980 to stop the population explosion that was occurring there, especially in urban areas. China's decline in fertility rates are shown in the graph at the bottom. However, the steep fertility decline underway prior to 1979 leads some experts to question whether the one-child policy was necessary. Like fertility, mortality is also another indicator of a pattern of population change. A standard measure of mortality is the crude death rate, or CDR, and is defined as the number of deaths per year per 1,000 people in any given population. And also, like fertility, there are certain factors that influence these rates. For example, natural disasters, the state of the country's healthcare system, wars, violent civil unrest, and an unusually high aging population. Mortality rates, however, do not really tell us about the quality of life. Two factors that do are life expectancy and infant mortality. Life expectancy is the average length of time from birth that a person is expected to live given current death rates. The map shows the life expectancies across the globe. Life expectancy varies between countries, but Africa has the lowest life expectancies of any continent. The expected length of a person's life has much to do with the access to medical care, nutrition, and sanitation. Therefore, life expectancy data can reveal disparities in health and well-being. The second factor that measures the quality of life is infant mortality. Infant mortality is the number of deaths of infants under 1 year of age per 1,000 live births. This indicator also signals poor health care issues, especially to pregnant women and to newborn babies. Please pause the video and answer the following. What personal responsibility do people have in regards to population growth? Should governments have the right to implement population policy on reproductive rights? Define your position. In your own words, using the text as a guide, be thorough and specific in your answer.